Rodi from IT department. Today I'll be presenting on one of the most intelligent and widely spread algorithms in artificial intelligence, the A-star or A-star search algorithms. In this presentation, I will explain what A-star is, how it works, and the meaning of its formula and how it's applied in real-world systems like GPS navigation and robotics. Mm, and introduction to A-star searches. A-star is the best first search algorithm that efficiently finds the shortest path between 2 points. It combines two strategies: uniform cost search, which focuses on actual cost, and greedy search, which focuses on estimated cost. Its decision making is guided by the formula f of n equal to g of n plus h of n, where g of n is the cost so far and the h of n is the estimated cost to reach the goal. The balance allows A-star to make smart choices and find the optimal path faster than the other search methods. Mm, Our next slide is key concepts and understanding the formula. The formula f of n equal to g of n plus h of n is the heart of A-star. G of n is the actual cost from the start node to the current node. It's what we already know. H of n is a heuristic, a smart guess of the cost to reach the goal. F of n combines both to estimate the total cost of the path. A star always chooses the node with the lowest f of n value, ensuring that each step moves us closer to the goal efficiently. And the next slide is example graph construction. Um, to see how A star works, let's look at a small example graph. We have nodes A, B, C, D, E, and goal. Each edge between them has a cost. For example, A to B has 1 and A to C is 3. Each node also has a heuristic value which represents the estimated distance to the goal. For instance, h of A equal to 7 and h of E equal to 1. This setup allows A star to compare possible paths and select the one that minimizes the total estimated cost. Our next slide is A star search execution steps. And here we start from a node A with the g of n equal to 0 and h of n equal to 7. Next we expand nodes based on the lowest f of n values: A to C, C to D, D to E, and E to goal. Uses a total cost of 10, which is the shortest path. This table clearly shows how A star systematically explores nodes and avoids unnecessary paths, ensures efficiency and optimality. The principle behind the next slide is the principle behind A star. A star works so well because it combines the strength of two algorithms. The first algorithm is greedy best first search, and the second algorithm is uniform cost search. Best first search, greedy best first search, which quickly moves toward the goal but might miss the best route. Uniform cost search, which finds the best path to explore too much. By balancing both past and future costs, A star ensures two guarantees. First, completeness. It will always find a solution if one exists. Next is the optimality. It always finds the best possible path. And the next slide is admissible and consistent heuristics. Mm, the success of A star depends on how good the heuristic function is. An admissible heuristic never overestimates the actual cost. For example, using straight line distance in maps. A consistent heuristic ensures that total estimated cost never decrease along a path. Consistency improves efficiency because nodes don't need to be rechecked. It is important to remember all consistent heuristics are admissible, but not all admissible heuristics are consistent. Next slide is real world applications. A-star searches many real world applications, but some of the important real world applications are maps and GPS. It helps find the shortest driving routes in apps like Google Maps or Waze. Next is the robotics. Robotics use it to plan safe paths while avoiding obstacles. Next is the video games. Non-player characters are also called as NPCs use A-star to move intelligently through environments. Next, network routing. It finds the fastest routes for data transmission across the internet. In short, anywhere optimal pathfinding is needed, A-star is involved. Next is the significance of A-star. A-star is considered a landmark achievement in computer science because it guarantees the best path while being computationally efficient, perfectly balances speed and accuracy, making it ideal for both theoretical and real-world applications. It is also a foundation for many advanced AI algorithms, showing how simple mathematical reasoning can lead to powerful solutions. Next slide is the summary and key takeaways. To summarize, the core formula of A star is f of n equal to g of n plus h of n. It's an intelligent search method that balances past, cost, and future prediction. With admissible heuristics, A star guarantees the optimal path. Overall, A star remains one of the most elegant, powerful algorithms in computer science, efficient, reliable, and widely applicable. Thank you for listening. I hope this presentation helped you understand how A star algorithm works and why it's such an essential part of AI in computer science. Thank you.